Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on November 20th, 2025, about 4 days ago. And this paper introduces Segment Anything Model 3, a unified system that can detect, segment, and track objects in images and videos from flexible concept prompts. It roughly doubles the accuracy of existing systems on promptable concept segmentation while staying fast and interactive. The paper is titled SAM3, Segment Anything with Concepts. And as we will see later, the combination of a new architecture and a massive concept dataset leads to some really impressive results. Also, the authors shared a pretty complete GitHub repo. You'll find the SAM3 Python package, scripts for running image and video inference, options for fine-tuning, and clear install instructions, plus a bunch of Jupyter notebooks that walk through text and visual prompting, batched inference, interactive segmentation, and SA company dataset evaluation. Figure 1 contrasts the older promptable visual segmentation with the new promptable concept segmentation, showing how interaction becomes richer and more flexible. This figure shows, on the left, the classic setup where a user clicks positive or negative points to segment one object in an image or video. On the right, the panels illustrate concept prompts that use short noun phrases like striped cat or hard hat, plus optional example boxes, to segment all matching instances at once. Figure 2 shows concrete side-by-side examples, where SAM3 segments open vocabulary concepts more accurately than the older OWL v2 model. Open vocabulary here means the models must handle arbitrary text prompts like a white flower or toilet roll holder, not just a fixed label list. The grid of images highlights that SAM3 finds more instances, outlines them more tightly, and misses fewer small or oddly shaped objects. Figure 4 explains how SAM3 actually processes a video frame so that prompts turn into tracked object masks. The figure shows a single pipeline where text prompts and exemplar crops flow through shared text and image encoders into a central detector and tracker module. This joint design means the same perception backbone serves both image detection and video tracking, which keeps the system efficient and consistent. A memory bank on the right stores past masks so SAM3 can maintain object identities across frames and merge new detections with propagated tracks. Figure 5 explains how the data engine turns raw media into clean training labels for concept segmentation. A data engine is a semi-automatic pipeline that repeatedly proposes labels and masks, then checks and corrects them, so the dataset keeps improving. The diagram shows images and videos flowing through mining, noun phrase proposal, and SAM3 mask proposal into candidate segmentations. AI verifiers and human verifiers then accept good candidates, flag incomplete masks, and send mistakes to a correction stage, which produces the final high-quality annotations. Table 1 shows that SAM3 is not just a bit better, it clearly dominates prior systems across almost every image concept segmentation metric. The table compares instance segmentation, box detection, and semantic segmentation on benchmarks like LVIS, COCO, SACO, ADE 847, Pascal Concept 59, and Cityscapes. SAM3 roughly doubles concept grounding F1 on SA Company Gold over the strongest baseline and gets close to human agreement. It also sets new zero-shot records on LVIS and COCO style metrics, which means the model generalizes well to concepts it never saw during training. Table 5 reports how well SAM3 tracks and segments objects and videos from text prompts, compared with humans in prior systems. Open vocabulary video instance segmentation means the model must follow any written concept, not just a fixed label list, and keep each object's identity across time. The table shows that SAM3 consistently achieves the best machine scores on the SA Company v-eval subsets and on public video benchmarks. Competing systems like GLE and LLM-DET lag far behind, especially when the benchmarks include thousands of different noun phrases. Alright, 2 takeaways stand out. SAM3 turns free-form concepts into accurate, tracked masks in images and videos, and the human plus AI data engine shows how massive, diverse supervision can unlock that capability. This could reshape interactive vision tools, robotics, and creative workflows. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.